should feel a bit comfortable with. Okay, so we, by this stage, think that integers are pretty easy. Okay, it's a primitive type in Java. We feel fine with that. Okay, we can declare an integer x and assign it value, and we are good with this. Okay, we learned a little bit additional information. Now we know that in Java we have 32-bit signed integers. Okay, so we now have a little bit more understanding about what's possible with this. Okay, so as a convenience, it's really useful to know what the largest possible number is. Now going and trying to work out the largest positive number, well, we know it's going to be, 2 to the power of 31 minus 1. Okay, that's a big number, several billions. Java makes it easy for us. We can get access to this largest number. We use the integer class, notice capital letter, dot, and I need to remind myself, max. I think it's all uppercase, value. Okay. And that will return us, or will replace this text with the actual largest value when the program is running. And as you can expect, if we have a max, we also have the min as well. So this is kind of useful. So Java helps you when it comes to boundary testing or testing at the extremes, because then we can ask for these values. Okay, we have the middle between positive and negative, which is 0. And then we have the two maximums. Okay, or maximum and minimum, I should say. Let me try to artistically draw a number line. Amazing how straight my lines can be with this tablet. Okay, so we have 0 in the middle when it comes to integers. Then we know we have all our negative values on one side, and then on the other, we have all our positive values. Okay. We also know that the smallest number is going to be minus 2 to the power of 31, and we know our largest is going to be 2 to the 31 minus 1. Okay. So this kind of gives us really good places to look. Okay, here is a boundary. Okay, we go from positive to negative. So it might be really useful to test the numbers around that transition. Okay, if we're testing a function that deals with integers. And also, so this is again, maybe I should write that. That is a boundary where we go from one side to the other, and including the middle. But also we have the extremes as well. Okay, interesting things happen at the extremes. We don't maybe often use these numbers, but they are at the same time there. So there are limits to what we can represent using integers in Java. So if I come back to my example, if I have x is equal to, just for clarity, integer dot max. What am I saying? I want to say value. Uppercase is hard. Okay. What's the answer to this question? What happens when you add 1 to this extreme value? Does Java warn you? Does it throw an exception? Number too big exception. Yeah, it certainly does not. Okay, so what actually happens is if we added 1 to that extreme value, it, as someone rightly said, it overflows and it loops all the way back to the smallest value. So just in your head for a minute, think that through. You're just sitting on the largest possible value, you add 1 more, and the answer you get next is the minimum value, which understandably sounds quite crazy, but if you go back to a simpler world of a 4-bit register, okay, and let's remind ourselves it's signed. and we have the value 7, which we know is the maximum. Okay, we have 7. We add 1 to this. Well, adding 1, I'm going to need another register below here to put the answer into. Okay, well, what is 1 plus 1 in binary? $10, exactly. 1 plus 1 is 10. Okay, so we represent that as well. We added 1 in here, so 1 plus 1 is 10. That means we carry 1 over here. We already have 1 there, so 1 plus 1 again is 10. And then 1 plus 1 again is 10. Okay, 1 plus 0 is 1. Okay, so now you can see just by adding 1 to that maximum value, we have overflown and flipped all the way back to the smallest possible value. Again, this is my simple 4-bit world, but the rules don't change whenever you have Java's much larger 62-bit signed integer range. Okay, so you could be just happily incrementing 1 to something, and it could just flip over to a negative value without you even noticing. And you're, of course, presuming that, yeah, we can just keep adding, we're always adding 1 on, it will always be positive. But due to this overflow, it flips all the way back to the largest minimum value. And again, you can just work through that simple example. So we know 7 is the biggest number we can have here. We add 1 to it, we carry all the 1s, and then we end up with only having a number inside the largest, or the signed bit, giving us this value. Okay, so this is how simple these things can happen. Okay.